Hi guys, in this video I will show that how we perform SDES encryption. So here what you are seeing is that the process of how this takes place. So first you will be provided with 8-bit plain text or the input, and then which is divided into 4 bits into half, and then it becomes 4 bits. So the right side or the right part, that is the 4 bits, will be provided to the EP, and where the operations are performed on it from the EP table, and then it produces the 8-bit output, which is XORed with the key 1. And this key generation video I'll provide in the description, and you can see that how we can find key generation. So this key is provided and is XORed, and after that these 4 bits are then converted into 2 bits using the S0 and S1 table, and which later on goes to P4 to produce 4 bits. And these 4 bits are then XORed with the left 4 bits of this plain text, and it produces 4 bits. And after that it is combined with the right side 4 bits of this plain text to form a 8-bit, which is then swapped, and then it becomes the input for the next round. And similarly we follow the same process and provide the key as K2, which is generated before, and then after the whole procedure is completed, we find the IP inverse, that is the initial permutation inverse, and it produces the 8-bit ciphertext. So now let's see that how we will do that. So in the question we will be given these input. For example, we will have the EP table, then IP table, and then P4 table, and S0 and S1, and IP inverse you might be given. So now this is the input for which we are performing the encryption, that is P equal to 0111 0010. Here I have written the numbers above it for our reference. So the first step what we need to do is find the IP. So in order to find the IP, we know that we need to perform the initial permutation in this order, that is 2nd bit in first position, 6th bit in second position, so on. So now we have 2 6 3 1. So second is 1, so 1 will come first, and then 6th bit 0, and then 3rd bit it is 1, and then we have the first bit, so 0. So first 4 digits are formed. Next we need to find the last 4 digits, 4857. So here it is 4 and it is 1, and then come to 8 it is 0, and then come to 5 it is 0, and then come to 7 it is 1. So now we have found the IP, and after finding the IP we will divide it into 2 parts, which I had shown in that slide. Let me show you once again. So here in this we can find that we have divided into total 2 parts, and after which the right part will be provided to the EP. So now how to find the EP? So in order to find that, in order to find the output of EP, we'll check this table, and here we will consider only the right part. And what we have to do is, for the 8 bits to be arranged, we will go in this order: 4 1 2 3. So now 4th bit in first position, so 1, and then first bit in second position, so 1 once again, and then second bit in third position, so 0, and then third bit in fourth position, so 0. And after that we have 2 3 4 1. So second bit in first position, and after that third bit in second position, and after that we have fourth bit in third position, and then first bit in fourth position. So this is the way in which we find the EP. Now once we find the EP, we have to do XOR with the key 1. So here you can see that once we have the output of EP, we have to XOR it with key 1. So now the key 1 which we have got is 10100100. You can see that how it is generated from the video link in the description. And so now in order to do XOR, we'll find the result that the XOR operation gives 0110 and 0111 as the output. So once again we'll divide this into 4 each, and this is called as S0 and this is called as S1. So now what you need to remember is you need to convert this 4 bits into 2 bits each. So now we'll check how to do that, and after converting it into 2 bits we have to give it to P4. So now let us see that what to do with this input to convert it into 2 bits. So now we'll go to the S0 matrix, and we have the input for S0 matrix as 0110. So what we will do is, in this you'll take the first and the last bit and together it will form the row. Similarly, the 2 bits in between will form the column. So here we have 00 as the row and 11 as the column, that is 0th row and 3rd column. So now go to S0 and 0th row and 3rd column. So we have the output of it as 10. So here we will output 10. Similarly for S1, we'll take 01 as row, that is first row, and then we have 3 as that is 11, that is 3 as the column. So here it is 1 and 3 as column, so it will be 11. So the output of S1 will be 11. Now we need to provide it to P4, and what we should do in P4 is the input for P4 which we found from here is 1011, and now we need to convert it to the output of P4. So for that we'll look into the output of P4, that is 2431. So second bit should be provided first, so here it will come 0, and then 4 that is 1 should come here, and then we have 3 and 1, that is third bit will come here and then first bit will come here. So this is the output of P4, and once we find the output of P4, now we should take the 4 bits of the left side and give it to it so that we can perform the XOR operation, and after performing the XOR operation we get the result as 1101. And now we need to simply put it on the left side, and we need to take the right 4 bits from the IP and put it beside it. So now we have the output as 1101 and 1001. Now we need to swap it, and after swapping we have 1001 and 1101. So this will be the 8 bits which will be the input for the second round. And once again we need to perform the same steps, except that the key which you provide here should be key 2. And after performing the entire operation you will get one more number, and after you get this number you need to perform the IP inverse, and the IP inverse order is this, and after you do that you'll get the ciphertext. So this is the way in which you perform the SDS encryption. So thanks for watching my video. Please do like and subscribe.